Hi, my name is Frank Paulian. I'm a senior electrical engineer major at the University of Scranton, and I am going to give you a little bit of an update on where my senior design robotics project is at this current moment. So basically, in the last video, I kind of went through some of the decisions that still have to be made, and some of the things that are really going to prevent progress from being made. So in this video, I'm going to kind of talk about some of the decisions that were actually made, talk a little bit about the warehouse and what we have planned for to basically represent that warehouse, and go a little bit more into the actual physical bot hardware of it all, and then kind of give a little bit of some of the decisions that yet to be made, that will kind of hinder us from making any progress after all of this is then completed. So I guess some of the big decisions that have been made for this project since the last video. We are going to use the Raspberry Pi microcontroller slash computer. This is pretty much due to familiarity with using it, kind of knowing everything about it and its ability to have quite a bit of information on it online. So instead of having to really figure everything out, we might be able to find more about it online that could really help us from reinventing the wheel, so to speak. So one of the downsides of using, or yeah, how about one of the reasons that we picked the Raspberry Pi, other than familiarity, it has quite a few GPIOs, or general purpose input output pins. Basically, this will be for all of our motors and sensors. Uh, we were able to find a device that actually it's a motor hat for the Raspberry Pi. It's essentially a device that allows us to have motor controls in terms of controlling two DC motors, a stepper, and a servo motor. All of this can be controlled through the Raspberry Pi, and these were the motors that were really deemed necessary since the last video. Um, so if I go into the physical bot a little bit more, the design behind it is going to be that uh, we use a 3D printed Micromouse chassis that has already been built for us. So in terms of actually constructing a entirely new vehicle, that won't have to be done to an extent. We still have to get the forklift system on top of the Micromouse chassis, but that seems like a simple um, part of the project right now. Another thing that we're going to have to do is figure out a way to connect all of our other types of sensors to the Micromouse chassis, and really just decide what we need in terms of all of our sensors. So right now, for the actual physical warehouse, our plan is to construct it out of wood, kind of get all of our shelves that we need. Right now, our plan kind of consists of something like this. Basically, from this, we have this would be where we would receive packages. This would be where the bots would be stored, or their home position. This is where they would be sent out. And basically, we would have one of these devices. We could have up to three. That's what our plan is now, but for simplification purposes, I only drew two here. So this device here labeled 1, it would be in charge of picking up packages at this location, bringing them to this center location here, where this bot would then be in charge of taking it from our packages from this location and putting them into storage. In terms of storage for our warehouse, we plan on having it broken into different sections based on the week that the package is due. Right now, we feel that it's best to just go with by week, and then as we have more time for the project, we will then integrate actual days that the package needs to be due at. So we kind of plan on breaking it down into maybe 1 week here. If it's due in 2 weeks, put it here, 3 weeks, and then the rest could be for 4 weeks and on. So after this, bot number 2 would store it in this location, depending on the time of the day. It would then move it back to the central location where robot 1 would then take it from that central location and put it in the out position, so for when it actually needs to be delivered. So in terms of maneuvering through that warehouse, we believe that using a line follower system would be the simplest in terms of actually achieving all the location and setting different markers to kind of let the robot know exactly where it is in the warehouse. So some of the options that we have for this, since we are using the Raspberry Pi, which doesn't have any analog inputs, we are working on getting a line follower circuit, so to speak, where we can either use a comparator to kind of give us a digital output for comparing analog inputs, where this would be controlled by a potentiometer, or another decision that could be made is using a ADC, or analog to digital converter, which they actually sell. They're pretty cheap, and we'd be able to use that to get really what we need for the line follower circuit. So I guess in conclusion, some of the decisions that really need to be made, we still need to think about a way to power the device, controlling 4 motors, and being able to power Raspberry Pi, multiple sensors, depending on which we actually end up going with. We need to be able to power it in an efficient manner that will be able to not the battery wouldn't run out every couple minutes, as we wouldn't be able to get the amount of testing that we need for this project. I guess another thing that needs to be decided is the actual organization method of how bots are going to communicate with each other, and basically how packages are going to be scanned, moved, stored in the warehouse setting. I guess some research needs to be made for that, in terms of finding an accurate way of doing this that could be maybe scaled up to an actual warehouse someday. And then for the last decision that really has to be made is going to be using the analog to digital converter, or having that line follower circuit that I mentioned before. After these decisions are made, we will be able to really progress with the project. Thank you.